again, and welcome to another INB382 demonstration video, and this one is on procedural lava. Well, this is quite a nice looking effect, so we'll just pop it on, I'll just show it to you. There you go, there is our sort of Io-like planet with an animation moving the lava across the surface. Not really realistic, but at least you get a sort of a feel that this is quite a nice sort of noisy looking, lava-y looking surface that could be used for generating planets that look this way. You might change the animation, or more appropriately, you probably set up some sort of ditch inside your environment and the lava is flowing through. Just as an aside, I saw this really nice game last year that our students generated, but the guys would not animate their lava, and that just makes me sad, because they could have had something looking sexy and exciting like this, and they just had a static planet in the background. Missed opportunities. Anyway, how do we generate this lava? Well, the first thing to note is that it's based upon the sort of Ito complex modeling that I mentioned in the lecture. The basis of it, first of all, is the addition of this sort of bark texture as a basis for the effect. You can see it here because it's not animating. We just got this really bright looking bark across the surface. And note the distortion at the poles and everything, so the textures are all because they're based upon the X, Y, Z coordinates. This is not a 3D texture, this is a 2D texture across the surface. But it's used to modulate, or is modulated by the noise. So again, we go to the script, and we've got our typical noise function that occurs. Blah, 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 blah. And that's all very pretty. And we add that into the system in order to enable some noise to perturb the bark and add some crazy colors to it in order to generate our Io-like planet. So moving over into the shaders themselves proper. Okay, most of the top part is just sort of various parameters. The bit that we probably want to focus on most of all is this here generation of really sort of fractured noise. Should put a line there. That's naughty programming. So in our pixel shader, we're just going to get the world position coming through that's been transformed. So that, that's all very good, and we pass that through. So that means we got where that pixel is in 3D space is going to be interpolated. So the pixel has a 3D space position, so we're calculating this noise in 3D space. Now the cool thing about this is that, remember, if we want to get sort of plasma-y, noisy style effects, we need to sum together 4 octaves of this noise at various diminishing scales. And this is what this loop does here. Go to the lecture to see the theory. And note that we can see here that the coordinates are multiplied by a factor through every iteration, and then divided by another factor. So this implements the sort of noise octave summation loop, and that gives us this sort of gnarly sort of noise, not the soft noise that we use for wood, really gnarly noise that we're using for the plasma. So gnarly you could surf it. Bad joke. Moving on. So we then use that world coordinate there, taking the X and Y value to sample from the bark sampler. So that's our basis. The basis is bark. But then, at the same time, we use that to generate a noisy version of it. So the value that comes out, the RND, is a noise factor. And that noise factor sort of makes everything look strange as it moves through the space. And then what we use for that is, okay, we then mix it together with the colors. So we've got lava color 1 going up here where we define lava color. We put it in the pixel shader, all good. So the lava color 1 is, a lot of red, a lot of green. So we've got a sort of hot yellow color. Here we then have the second lava is a fairly bright red, so from red to yellow it ramps through. So what occurs then is that the texture modulates the lava color. That's all very good. But then that is also affected by this noise. It's appropriately scaled and translated so that we get this admixture of a noisy red to a base yellow for the colors. And then, as mentioned, you've got your structure, which is the bark. It has a fairly noisy structure, but that's your base system. And then adding to that, you add your noise, which gives you this sort of plasma-like effect in real time across the surface of the object, as we see here when we run it. So lo and behold, this can be used, of course. You could always just sort of go through the colors. You don't have to move them in space, but also you can just simply go through the colors as an interpolation, and that would give you probably stationary effects with color. You can play with this, but as you can see here, you get this really nice plasma-y effect, and that's very good for representing a sort of animated form of lava. Of course, you can work on this. You can make it less gnarly. Maybe you want to make it a more smooth, rounded lava. This is up to you. The choice then is to use this judiciously in your games in order to create these sort of effects. But note, it's very useful if you were to change this, say, from a white to a blue color, you get something that looks like marble. And that's quite useful if you're doing the tutorials and looking at the other examples I show in the lecture. So I suggest you check that out. Apart from that, that's the end of the lava plasma demo. Thank you very much.